Alright, so our first problem is on page 228, and it's number 81, and it reads, consider the flasks in the following diagram. What are the final partial pressures of H2 and N2 after the stopcock between the two flasks is open? Assume the final volume is 3.0 liters. What is the total pressure in torr? So step one is to write an equation for it, and in this instance, it would be partial pressure of N2, so PN2 plus PH2 equals P total. Step two is to plug in all the values for that. So partial pressure of N2 is equal to 475 torr times 2.00 liters plus 0.2 atm times 760 torr over atm times 1 liter equals P total times 3 liters. Alright, so step 3 is to solve the equation, or can start solving the equation. So we start by multiplying 475 by 2 and 0.2 by 760, and we get 950 torr plus 152 torr times 1 liter all over 3, which equals 367 torr. And step 4 is just to write out all the values of the partial pressures and then the total partial pressure. Step 4. Alright, so partial pressure of H2 is equal to 317 torr. Partial pressure of N2 is equal to 51 torr. And the total partial pressure is equal to 367 torr.
So for page 228, number 82, the question reads, consider the flask apparatus in exercise 81, which now contains 2 liters of H2 at a pressure of 360 torr and 1 liter of N2 at an unknown pressure. If the total pressure of the flask is 320 torr after the stopcock is open, determine the initial pressure of N2 in the 100 liter flask. So first what you want to do is you take the pressure of 360 torr times 2 liters of gas in the flask, and it equals the partial pressure of the N2 times the total volume of the container of 3 liters, which after you divide the 360 times 2 divided by 3 to get P2, P2 equals 240. So to find that H2 is 240 torr. Next, subtract the 240 from the total pressure of 320 to get that 80 is the partial pressure of N2. to find the initial pressure of N2, you multiply the partial pressure of 80 times the total volume of the flask, which is 3, to get 240 torr. Our next question is on page 807, number 12, and it reads, when the environment is contaminated by a toxic or potentially toxic substance, for example, from a chemical spill or the use of insecticides, the substance tends to disperse. How is this consistent with the second law of thermodynamics? In terms of the second law, which requires the least work, cleaning up the environment after it has been contaminated or trying to prevent the contamination before it happens? And explain. So if the contaminant were to be introduced to the environment, it would likely disperse, increasing the amount of disorder. As disorder increases, the work that must be done will also increase in order to overcome it. This is why, in terms of the second law of thermodynamics, it would be more practical to prevent the contamination rather than to clean it up. As a contaminant disperses, there would be a larger area to decontaminate. For example, if you were to take a deck of cards, right now, it takes less work for me to hold it than if it were to, say, be spread out all over the place. Then I'd have to go and pick up each individual card, which requires me to do more work than it would for me to just hold the cards in the first place.
Alright, so the next question is on page 807, number 13, and reads, entropy has been described as time's arrow. Interpret this view of entropy. So, first off, time and entropy are both continuous. This means that they're like an arrow. Always go forward, never go backwards. So this is why entropy is described as time.
Our last problem is problem number 102 on page 281. Consider the following changes, and at constant temperature and pressure, in which of these changes is work done by the system on the surroundings, by the surroundings on the system, and in which of them is no work done. Part A, N2 gas to N2 liquid. Work is being done by the surroundings on the system. Part B, CO gas plus H2O gas yields H2 gas and CO2 gas, in which case no work is being done. Question number C, Ca3P2 as a solid plus 6H2O liquid yields 3CaOH2 as a solid plus 2pH3 as a gas, in which case work is being done on the gas by its surroundings. Part D, 2CH3OH as a liquid plus 3O2 as a gas yields 2CO2 as a gas and 4H2O as a liquid. And in this part, work is being done by the surroundings on the system. And in part E, I2 solid yields I2 gas. And in this case, work is being done by the gas to the surroundings. Thank you for watching.